Hey everyone, this is mini lecture number 15 for Computer Science 163 at the University of Wisconsin-Eau Claire. I'm Jess Reisma and I will be talking about how to use classes. Specifically, we'll be talking about the different kinds of methods in a class and going through some examples about how to implement them. To prepare for this, I encourage you to read chapter 9, sections 4 through 6 in our textbook. Self-check. Pretty much go through the last mini lecture. Make sure that you understand at least maybe 60%, 70% of what's going on, and then see if you can explain the following things. Now, last time I encouraged you to try thinking about this. Suppose we have a lot of work to do with rectangles. So you're working on a project where there's tons of rectangles. What member variables would you give a rectangle? What functions or services would you provide for rectangles? Now I encourage you to really think through this for a little bit, if you haven't already. Just write a few things down, jot some quick notes. It takes 30 seconds, maybe a minute. What kinds of variables would you give to a rectangle? And then what kinds of things would you want to ask a rectangle? What would you want to know from a rectangle? What would you want to calculate about a rectangle? What would you want to change about a rectangle? So create methods for those. And in just a sec, I will go on to the next slide, which has a bunch of things. So 3, 2, 1, here we go. So here is what a class declaration would look like. So this is, when we say class declaration, that means we're declaring a class called rectangle exists. And here is what it looks like. Here's the interface. So you notice that there's a public section and a private section. The public section, as you recall, are all of the different things that everybody will have access to. So remember, when we encapsulate things, we're hiding some information from the rest of the world. We're putting it all together in a common place. If you have just a public class, then you're not really encapsulating things because you're not hiding things. You're encapsulating them in the sense that you're putting them all together in kind of like a shell called a class, but there's not so much hidden. Now in this case, we do have two hidden private variables at the bottom. Double my width and double my height. Now those are the instance variables of this class because every rectangle needs to know how wide it is and how high it is. So we're going to look at each of these different sections of methods in the public section up above. Those are the ways that the rest of the world is going to be able to use the rectangle class. The variables at the bottom, nobody else is going to have access to those. They're going to be hidden from the rest of the world. And that's for safety. We don't want anybody messing with a rectangle. We want to be the only ones messing with a rectangle, and we want to let them mess with our rectangle, mess with those instance variables, only on our terms. Last time I briefly mentioned what a constructor is. Let's talk about it more in some detail here. A class constructor tells the computer how to initialize an object of a given class. So if I have a vector object, then a vector class will have a class constructor that says, here's how you build a vector. It would set the initial size of the vector, it would set the initial data of the vector, and any other instance variables or data members contained in that class, it would initialize them appropriately. So the rectangle constructor will initialize all of the instance variables or data members of the rectangle class. And there can be more than one kind of constructor. So we'll talk about 3 of those constructors here. The first and most basic one is the default constructor. So you would use this when no arguments are given. So for instance, if in my main method I call rectangle and then rect. Rectangle is the type of the variable, which is of our class. We defined a class called rectangle, so the type of the variable is rectangle. And then we're calling the variable, we're naming it rect. So rect is going to be a new variable of type rectangle. Now implicitly, if it was just like an integer called I, we'd say, oh, it's not been initialized, it has some garbage value. Here it's different. When you declare a variable of type, say, rectangle, it's going to call that class's default constructor if you don't say anything more about how to build this. So no class variable will ever be totally uninitialized. It's always going to have some kind of initialization, even if that's the default initialization. Another kind of constructor that you can have is the explicit constructor. And the explicit constructor is the one that will be called when there are certain initial values given for each of the member variables that you have. So if you have 5 different instance variables in your class, then the explicit constructor is going to be the one that is going to, where the user can actually set specific values for each one of those. So here, in this example, I'm declaring a rectangle called rect, and I'm giving it the values 2.0 and 4.0. Then the compiler is going to call a rectangle double width, double height. That's a function in the rectangle class. It's the explicit constructor function. And it's going to use the width that I give it, 2.0, and it's going to give the height, or it's going to use the height, 4.0, as the width and the height of my rectangle. So there it's explicit because I'm explicitly specifying what each of those variables are, corresponding to each of the instance variables under the hood. Another kind of constructor is the copy constructor. So what this is going to do is it takes the initial values from one object of that class and copies them into this new object. So here, if I have some other rectangle called, creatively, other rect, then I can pass that in these parentheses to the rectangle called rect. So here I'm declaring a variable called rect and initializing it using this other rect as from my source. So it's going to take that other rectangle and copy its width into this rectangle, and it's going to copy the height from that other rectangle into this rectangle. So that's why it's called a copy constructor, because it's copying the values from one rectangle into this rectangle. Now I'm going to go through each of those constructors in a row. So the first constructor is the default constructor that we talked about, and the default constructor would look something like this. Now, whenever you define a method for a class, you usually do it outside of the class. You can do it inside of the class too. I'm not going to worry about that now. But usually you define the methods for a class outside of the class. Now when you do that, you have to tell the compiler what classes this method belong to. So you do that by using this colon operator. The colon operator is called the scope resolution operator. So here we see rectangle, colon, colon, rectangle. The first rectangle before the colons tells us that this method will be part of the rectangle class. And then the rectangle after those two colons tells us that's the name of the method. So this is the rectangle method of the rectangle class. Now, that's because this is a constructor, and the constructor will always use the class name as a class method. So there you go. Now notice another thing that's funny about this function is that it doesn't have a return type. Usually you always see something like void, int, string, ampersand. You see something like that before the method name. Here that's entirely missing, and that's on purpose. This is one exception to that rule. Every other function needs to have a return type except for constructors and destructors, but we won't talk about that either. So a constructor doesn't have to have a return type because it's not returning anything. Its job is not to return anything, void or otherwise. It'll always return void. What it's doing instead is it's building an object. It's constructing a rectangle in our case. Okay, so that's what's going on with the syntax. Now remember from the last slide too that we had the instance variables under the private section called my width and my height, and they were of type double. What I'm doing now is I'm saying for the default constructor, what should the default width and the default height be? If the user doesn't specify what they are, what should we have them be? Now that's an interesting thing because normally when I initialize a variable, it'll have just garbage values from whatever was left in memory under the hood. So if I say like int a and then do cout a, it'll print out, I don't know, whatever. It'll print out garbage. But with class objects, it's a little different. They're never left completely uninitialized. So what we do is we build a default constructor, and the default constructor will give it default values. And that will be called if you don't actually construct it. Okay, so backing up, here default values for the width and the height are just 0. If the user doesn't specify what the width and the height of the rectangle are, let's just give them a height and width of 0, just by default. Moving on to the explicit constructor, again, no return type. And we also have that rectangle colon colon. Again, that's telling us that it's the rectangle function in the rectangle class. Now, whereas before we didn't pass any variables to the constructor, here we're passing two doubles, one called width and one called height. And so what we're doing is we're going to set my width, my instance variable, the actual width of the actual rectangle, equal to this new value width, and setting the height equal to this value height. So it's called an explicit constructor because it's setting those values explicitly. The copy constructor, this is the rectangle method of the rectangle class. And here we're going to pass in a const rectangle reference called other. So we're going to pass in this constant rectangle, and again it's constant because we're copying from it. We shouldn't change that other rectangle. We're going to look at its width, and we're going to set our width equal to that one's width. We're going to look at its height and set our height equal to that one's height. So that's the copy constructor. Now let's talk about getter methods, or accessor methods. Accessor methods helps you actually get some of the guts of what the class has. So if we want to access, if we're looking at the rectangle class, we would have these two. Our two instance variables that are private from the rest of the world are my width and my height. So nobody has access to those. But what if somebody wants to know what the width and the height of the rectangle is? Why would you have a rectangle in the first place if you don't want to know its width and its height? Well, you can provide these functions to get those for them. So now you can say, get the width of this rectangle and get the height of this rectangle. Now here, both of them return type double. Both of them have void as, you don't have to pass anything to get the width. You're just saying, hey, rectangle, yo, what is your width? And then it returns its width. Now, you notice there's a const at the end. That means that as a result of calling the getWidth function on a rectangle, then that rectangle shouldn't change its value. So it's like, if I ask a person, what's your height? The person can say, hey, here's my height. And it doesn't change how high they are. It shouldn't change how high they are. Or if I go into a bank account, for instance, and I say, what's the balance on my bank account? The bank account better make sure that by me asking what my balance is, I'm not going to somehow change the balance of my bank account. If that were the case, I'd be doing it all the time, or I wouldn't be banking with them because that's stupid. But the point is, by asking a rectangle what its height or its width is, I shouldn't be changing the height and width of the variable. So putting the const here makes sure that that can't happen. And if it does happen accidentally, then it will generate a compiler error. So here's how you might code the getWidth function. Again, you have a return type double, and then you have rectangle : : that's telling us that it's part of the rectangle class, and then : getWidth, that's the function name. Void, we're not passing anything to it. Const, again, that means that we're not changing the rectangle. And then we're returning the rectangle's width. We're saying return my width. GetHeight is almost identical, except it has a different function name, and instead of returning my width, we're returning my height. So every rectangle will have its own values for my width, and they'll have their own values for my height. And so if you ask a specific rectangle, getWidth, sumrect.getWidth, or sumrect.getHeight, it'll return that width or that height for that rectangle, and not for all the others. So it's kind of cool. Now we have modifier methods, or setter methods. What setter methods do are they help us to be able to assign values. Oh, my water almost spilled. They help us assign values to the member or instance variables of the class that are otherwise hidden or private. And we said that we want to hide these variables away from the rest of the world. Why do we want to be able to ask what their values are or set the values? Well, for something as trivial as a rectangle class, there's really no point into having a getter method or a setter method, but for much more complicated methods, or for more complicated classes, it's a really good thing to do. At any rate, it's a good practice to be able to hide those variables away in general, and to only provide access to them via getter and setter methods. So that's why we're doing it. For the rectangle class, we could have two methods, one saying set the width, and one called set height. So this is how they would look when you're declaring the class in the public section of your class. They return void, because you're setting a width and you're not getting a width in return. And then each of them take a double argument, and that's going to be like the new width that I'm setting it to, or the new height that I'm setting it to. So then here's how I would code that method up later. After I've declared it outside of the class, I would say void rectangle : : again, I'm saying this is part of the rectangle class, and then set width is the method name, double new width is the new width of the rectangle. So I'm saying I want to change this rectangle's width to whatever this new value is. So I say my width equals new width. Now, if you were being extra careful in your rectangle class about making sure that you don't have negative widths or no negative heights, you might want to check here and say, hey, is this width negative? If so, maybe return an error or something like that. But let the user know that, hey, this is not okay. I can't do that. I can't set it to negative. This is why we would make sure that these variables are private. If you wanted to make sure that your rectangle doesn't have negative values, you could do that by saying, I'm going to hide those values away from everybody else. So they couldn't just do, SumRect.myWidth equals -10, some horrific negative value. Instead, you say, no, you can't actually access those variables. They're hidden from you. But you can try to set their values by going through set width, and set width will check then and say, hey, is this value legit? Is it okay for this class? If it's not going to touch those values. So it's a way you can add some extra security to your classes. And debugging help too. So here's the set height method, and it's basically identical to the set width, except you're dealing with height instead of with width. Okay, so C++ has this concept of overloading methods. And overloading methods is when you have two different functions or methods that have the same name, but they have different input arguments. So they're meant to do basically the same thing, but they do it using a different set of inputs. An example of this might be, let's say that you have a function called sum, and you want to add an integer a to an integer b. So this function would be pretty simple. You just return a plus b. And so this does integer addition. Okay, that's fine. Now, if you wanted to overload that, you might see like, well, okay, this works for integers, but it doesn't really work if I have, floats or doubles. Because if I do that and I pass, 3.1 and 4.5 into sum, it'll cast them as an integer and it will only add the integer values of those, and it'll get the answer wrong. So I need to make another function called sum for doubles. So now if I do this, it's basically the same function. I'm still doing return a plus b, but now it's doing it for variables of a different type. So what I've done is I've overloaded the sum function. So instead of taking two integers and returning an integer, it takes two doubles and returns a double. So now those are overloaded methods there. Now we saw another example of an overloaded method in the constructors that we saw earlier. Notice that they were all the rectangle function from the rectangle class, but they had three different sets of arguments. One with no arguments, one with the width and the height, the explicit, and then one with passing in another rectangle. So that was the copy constructor. Each of those represent an overloaded method. We're overloading the rectangle method of the rectangle class to behave three different ways based on what inputs you give it. Now, another cool thing that you can do in C++ is that you can actually overload operators. So you can choose what assignment operator means. You can choose what the the equality operator means. You can decide what the less than operator means and the greater than operator means. So this is a really cool and really powerful thing that you can do in C++. Sometimes you do it, sometimes you don't. It's good for most classes to do this for at least the assignment operator. Now here are three operators that we're going to consider in this mini lecture. One is the assignment operator, the first one. The second is the equality comparative operator, and the other one is the inequality comparative operator, saying are these not equal to each other. Let's look at the equality or the assignment operator first. In this one, it's going to return a reference to a rectangle, and then it's going to be the equality operator of the rectangle class, so rectangle class : operator equals. And then in parentheses, what we're going to pass this is a reference to another rectangle. And I'll show you how to use these, how to call this in just a little bit. But for now, I want to show you how to define these methods. So here, what we're going to do is we're going to take my width and set it equal to the other's width. we're going to take my height and set it equal to the other's height, and we're going to return this. We're going to return a reference to this rectangle. And that's to allow for chained equals. So like rectangle A, rectangle B, rectangle C, and then you say A equals B equals C. If you didn't return this, it would just be, and you just return void, you could do A equals B or B equals C, but you wouldn't be able to do A equals B equals C. So anyway, complicated, we won't talk about it now, but that's why we do return something. And why do we return star this? That's a fancy notation. It's called the dereferencing operator, and this is a pointer to this rectangle that we're operating on right now. Not going to worry about that for now. It's a little beyond the scope of our class right now, unfortunately. Hashtag COVID-19, taking away our class time, but that's what you can do. Another operator that you can use, or overload, is the equality operator. So this is going to return true if this rectangle equals another rectangle, and it's going to return false if they're different. So notice the return type is bool, true or false. It's in the rectangle class. It's called operator equals, so that's the method name. And we're passing it a const reference to another rectangle. The last const in that line is reminding or telling the compiler that this method will not change this rectangle, my rectangle, the one that I'm working on right now. So if I say, you know, rect A and then rect B, two rectangles called A and B, and I say A equals equals B, it's going to send the equals equals operator to rectangle A using rectangle B as an argument. So in that case, A would be this rectangle, B would be the other rectangle in parentheses here, the one on the right-hand side. This rectangle will be on the left-hand side of the doubles equals. So then it will look at my width of rectangle A. Does that equal my other, rectangle B dot my width? And if it does, then and my height equals other my height. So it's basically saying, are the widths equal? Are the heights equal? And if they're both equal, then return true. And if either one of them is false or both of them are false, then return false. Now, the other one, the inequality operator, we could just say return not equals, this equals other. But that's kind of boring. So we'll just do it the long way here. This method is basically the same as the equals method in that we're comparing the width and the height of this rectangle and the other rectangle. But here we're saying, we're asking, are they not equal to each other? Return true if they're not equal to each other. Return false if they are equal to each other. So here we're going to return the result of saying my width is not equal to the other width, or my height doesn't equal the other one's my height. So if either one of those is not equal to the other's value, then return true, because that means that the two rectangles are not exactly equal. Let's now switch gears and look at the utility methods. These are oftentimes the most useful methods in a class, other than just getters, setters. Constructors you always need, and other than like the operators. So utility methods are very, very useful. So for the case of a rectangle, you might want to say, hey rectangle, what's your area? What's the perimeter? Those are like questions where you're asking it something like, hey, what's the value? And for those reasons, we want it to be const, because if I ask a rectangle what its area is, I'm not asking it to change its width or its height, so it should be a constant width and constant height. So I'm putting the constant there to tell the compiler I'm not going to change the rectangle by calling the calc area or the calc perimeter functions. Now the scale by function is different. For that, I'm going to say, hey, I want you to multiply your width and your height by some scale factor, maybe 2 or maybe 0.5 to shrink it. And so in that case, it's not going to be const. It's going to be very much not const. I want it to change. So let's see how those would actually work out. Here are the three methods. The first one, again, it's in the rectangle class, the calc area function. It's returning a double. The input for calculating the area is void. I don't need to know anything to calculate the area of a rectangle. I can just ask the rectangle, what's your area? And the rectangle keeps track of what the width and the height are. And so the rectangle will tell me. And the const means that I'm not changing the width and the height of the rectangle. So return my width times my height. Now to calculate the perimeter, that's just the width plus the height plus the width plus the height, so twice the width plus twice the height. I can just return that there, that's the perimeter. And then scale by. So the scale by method in the rectangle class returns void because there's nothing to return. It's just changing it. And then it takes in this scale factor. So 2 if you want to double the rectangle's height and width, 0.5 if you want to scale it by a factor of half to shrink it. What it does is it takes my width, multiplies it by scale factor, and sets it equal to itself. So my width times equals scale factor, again, is just my width equals my width times scale factor. My height equals my height times scale factor. So you're scaling the width and the height of that rectangle by that factor. So I know you're probably thinking that this has been a lot so far, and I agree. So what I want to do is I want to take a step back and say, how do we actually use the rectangle class? And it's going to be a little bit weird, and it's going to be pretty awesome and pretty straightforward. So what I've done is I've written a file called testRectangle.cpp. This is going to contain the main method that's going to contain the code that we'll use to show off the rectangle class. So I'm going to #include IOStream, the header file for all the IOStream stuff like cout, using namespace std as usual. And now I'm going to #include rectangle.hpp. Now notice, first of all, rectangle.hpp will be the header file that will contain the rectangle class, and I'll talk about what that means in a sec. But notice that it uses the double quotes instead of the angle brackets. That's because the angle brackets tell the compiler to look in some special standard place for the special standard header files like IOStream or string or fstream and these other ones that are standard C++ stuff. If you write your own header files like rectangle.hpp, you're going to need to use strings, the double quote marks to say don't look in those standard places. Instead, look in the current directory or another directory that I specify. And since you didn't define rectangle.hpp to be part of some namespace called std, we don't need to use a namespace. Don't worry about that. You just use a namespace for the standard stuff, usually. So here's our main function. I'm going to declare a rectangle called 0rect. Now 0rect, if you notice here, I've not initialized it to anything, right? Wrong. I'm actually initializing it using the default constructor. So when I say rectangle 0rect and then semicolon, it's going to implicitly call the default constructor with 0 arguments in order to initialize this rectangle object. So 0rect is going to have, according to our default constructor, we said 0 width and 0 height. So it's already initialized to have 0 width and 0 height, which is why I called it 0rect. So I'm going to then output all the values of this rectangle. So 0rect has this width, this height, this area, and this perimeter, and that's it. Now notice here, I'm doing 0rect dot getWidth. That dot right there is telling the 0rect, it's sending a message to it and saying, call this function on yourself. So tell me your width, tell me your height, tell me your area, tell me the perimeter. So whenever you have an object, a class object like 0rect, which is a member of class rectangle, when I do dot getWidth, the compiler is going to look at the rectangle class and look for the rectangle : getWidth function. It's going to find that and it's going to link it to this spot in the code right here where it says 0rect.getWidth. But in that function, wherever that function, inside of that function it says myWidth, it's instead going to use myWidth from 0rect, because 0rect might have a different width and height than some other rectangle. So that's the magic of classes in a nutshell. They each have their own copy of myWidth and myHeight. And so when I call a function on them, it's going to use those copies of those variables, the individual instance variables of that instance of the rectangle class for calculating stuff using those methods. So when I do that, it'll output this because 0rect again has 0 width, 0 height because it used the default copy constructor, and therefore it has 0 area and 0 perimeter. Next, we're going to use the explicit constructor. We're going to pass it a width of 2.0 and a height of 4.0. And we'll output all of this information as we did before. And this time we're using rect.getWidth, rect.getHeight, and so on, instead of 0 width, because rect is a new variable that has two variables under the hood, my width and my height. And that width will be 2.0 because we initialized it via the explicit constructor, and its height will be 4.0 via the explicit constructor. So when we output this, sure enough, that's what we get. And finally, let's try using the copy constructor. So I'm going to take that last rectangle on the previous slide, and I'm going to try to make a new rectangle based on the other rectangle called rect that we had in the last slide. So copy of rect is going to be initialized using the copy constructor, and it's going to be based on the rectangle from the previous slide. So if I output all of this, I should get that the width is 2, the height is 4, the area is 8, and the perimeter is 12. Next, let's try to do some other methods. Let's set the width of one of the rectangles to 1.0. So let's take rect, which had a width of 2 and a height of 4. Now we're going to set the width of that rectangle to 1. So let's output what its values are now. Rect, after setting width to 1, and we do that. And I'd like you to kind of think for a second and think what the output of this function will be. So pause it, and I'll show you in 3, 2, 1. This would be the output. The width is now changed to 1. The height is still the same at 4. The area is now the width times the height, so 1 times 4. And then the perimeter is twice the width plus twice the height, so 2 times 1 plus 2 times 4, and that works out to 10. So it works. The height function will work the same way, so I won't focus on that now, but let's focus on this scale by function. So let's take that rectangle, which is now 1 by 4, width of 1 and height of 4, and let's scale that by 2. And now notice I'm still using the same name. The variable itself is still rect, but it's now going to be changed. Its width is going to be double what it was before. Its height is going to be double what it was before. So I want you to think about what the output will be. And I will move forward in 3, 2, 1. Here's the output. So rect, after scaling by 2.0, will have a width of 2, a height of 8, area of 16, and a perimeter of 20. And I'm curious I hope that's what you got too. But if you have any questions, let me know. And we're just going to call this the end of the program. I'm actually going to post this all to Canvas as well, and you can see it. And I've got a bunch more functions there as well that test the operators, so the assignment operator, the equality operator, and the inequality operator. So I encourage you to go and check it out. Now, this is all well and good, but when you have multiple files defined, it's a little bit harder for Geany to know what to do. Geany is not a compiler. A compiler knows how to take things and make programs out of them. Geany is an IDE. It's an integrated development environment. So it uses a different compiler, the G++ compiler for most of us, to compile the programs that we have into an executable code. But doing so is kind of a complex process, and when we have multiple files, it gets a little more tricky. So let's talk about how to do that. The first thing we need to do is to create a project. Now we're going to have our testRectangle.cpp be one file, we're going to have rectangle.cpp be another file, we're going to have rectangle.hpp be a third file. Rectangle.hpp and rectangle.cpp are going to go together. They're going to define together, they're going to be the definition of the rectangle class. And then our testRectangle.cpp is the one where we test it and we demonstrate and showcase its abilities. So in Geany, in order to compile all of these together, we need to create a project and tell Geany how to do that. So go to the project menu and go to new. So new project. Enter a name for your new project. It'll create a new directory, if you need to. For Mac, it'll do that in your home directory. It'll create a new directory called your username / projects / and then whatever you call your project. So rectangle might be the project name here. In Windows, it might be under My Documents. I'm not quite sure, but you can check to see what that will be. Next, we need to tell Geany how to compile our project. Now this is the most complicated step of the entire bit. We need to build something called a Makefile. Now a Makefile is something that's quite a bit more complex, and to really understand how a Makefile works is totally beyond the scope of this course. It's something that I'm teaching my 252 students, and they're computer, by and large, most of them are computer programmers, CS majors. That's not the point of this class. However, because Geany is not able to do this itself, we need to do it a little bit on our own, but only a little bit. So on the next slide, I'll give you an example of how to do that. So what we're going to do is, instead of compiling a single file like we did before, we're going to need to make or build the project using this command. So we'll go to the build menu and select either make or make all once you've built that Makefile. Now once you've done that, if you press make or make all, it'll try to compile each of the files separately, and then it will try to compile them all together, linking them together, that is. And it will either have lots of compiler errors, or it'll all work and say compilation worked successfully. There's nothing to do. If that's the case, if you get to that point where it's compiled successfully or there's nothing to do, then you can run the program. So to do that, go to the build menu and hit execute. And once you've done this once or twice, at least in my experience with the version of Geany that I have, then I'm able to get it to actually, I can use the buttons at the top of the Geany editor window. But until then, I suggest you just go to the menu bars at the top. Geany's cool in a lot of ways. This is not one of them. Here's an example Makefile. Without going into all of the details, there is a little bit of stuff at the very top. Don't worry about that too much. The three things at the bottom are three recipes. So the one, each of them saying it's a recipe. It's basically saying how to build each one of these parts. So rectangle.o and testRectangle.o, those two recipes are saying let's compile the testRectangle.cpp and rectangle.cpp. There's dependencies. You can look up how to build a Makefile somewhere else. I'm not going to go into too much detail. But it's basically it's compiling each of those two CPP files using the header file, the rectangle.hpp, compile that, and put it into a .o file, which is an object code file. That's machine code, but it's standalone. So testRectangle.o contains the machine code version, the translated checked for syntax version of testRectangle, but it's not yet a full program all by itself because it doesn't have anything about a rectangle yet. The rectangle.o file is object file, so it's machine code. It's compiled, translated code, checked for syntax from the rectangle.cpp file, but it doesn't have anything about, it has no main method or anything else. So both of those things by themselves aren't a program yet. They're basically pieces of a program that need to be put together. So the very top recipe, testRectangle, that takes those two .o files and compiles them together, or actually links them together, building a new executable program called testRectangle. That's Makefiles in about 2 minutes. The all above that, all : testRectangle, that just says make this one file, and then that's it. .phony means this isn't going to produce a file called all. That's Makefiles in 2 minutes. Common errors when you're doing this approach in Geany or using Makefiles in general. The first one is no target specified, no Makefile found. Stop. You get that if you haven't written a Makefile yet, or you've written a Makefile and it's a different name, maybe like Makefile with 2 L's or something like that. So just make sure that the Makefile is there and it's in the same directory as the code. Then undefined symbols for architecture x86-64. Yeah, exact architecture might be different for you, but that's probably what it is. And then there's a lot of other weird things that follow. Basically, that's an error that can happen if you tell Geany to build something rather than to make your project. So maybe you were pressing the build or compile buttons on your window rather than going up to the build menu and pressing make. If you have other errors or issues, I really encourage you to talk to me in Discord. I'm happy to help, even after this semester is done. I love seeing you guys again, and I'd love to chat with you and catch up a bit. So let me know. My plan for this coming Tuesday is actually to go through all of those steps that I mentioned on the previous slides, so you have a chance to see me doing it and to follow my steps and to see if you can get some of the same stuff. So basically like a Q&A tutorial session. In the meantime, here are some quiz-style review questions. What are the 3 kinds of constructors? When I declare a variable of a given class type, is it always initialized? What does it mean to overload a method? What is a getter? What is a setter? What does writing const at the end of a member function signify? And I'll have answers to this at the end of this lecture. Practice problem number 1. Try to get Geany to run the source code in this mini lecture. It's a bit of a challenge enough just to get this running and to understand everything that's going on. And it's going to be hard for you to be able to test your understanding of what's going on at all unless you're able to even get something to compile. So I encourage you to just try to get Geany to get this to compile. If you are able to do that, try writing a similar class for an object called circle. Provide similar routines to the ones in the rectangle class, although some of them might be different. For instance, you don't want to have a getter and setter methods for my width and my height. Instead, you might want to have some variable called my radius and set and get that. But other than that, I encourage you to try to make a new class called circle. And then if you're really up for a challenge, if you want to grow, I won't expect you to do this for the end of the semester, try creating an abstract base class for both the rectangle and the circle classes, and call this abstract base class the shape class. Now this requires you to investigate how to write an abstract base class. There's a clue in mini lecture number 14. It involves virtual and equals 0 for some of the functions. Don't worry about that so much for now, but if you want to do this challenge, you're going to need to do it. So if you want, go for it. Or if you want to come back to it later, after the semester's done. It's awesome. Here are the answers to the review quiz questions. I hope that they've been helpful to you and that they're useful. Expect to see some questions like this on the exam. So that's it. I hope you guys are doing well, and I will talk to you later. Bye-bye.